Hello, students. Mr. Murphy here. We are talking about functions today. So let's take a look at our uh, stuff. So it's lesson one, module five. And we're talking about functions, and we're going to analyze nonlinear data sets. That means we're going to take a look at a table and see stuff that could be straight lines or might not be a straight line. And we're going to realize that the assumption of a constant rate of motion is not always right for everything. Okay. You'll explain the difference between a linear and nonlinear function, and you'll understand when you can figure out a rule that can be graphed without going straight up or backwards. So a function is really just this. So a function says if I graph something, it's going to go across the graph. So far, we've only had straight lines, and a straight line is a constant growth. So if I put in a 0, I'm at like 2.5 here. If I put in a 2, I go up to like 3. Okay, so the function is rising at a steady pace. If I put in a 4, I go up to like 3.5. So I'm going up 1 and over 1, 2, 3, 4. Go up 1, go over 4, or something like that. Okay, actually, I think it's going up a half and over 4. So if I go up 1, I'd go over 8. But anyhow, so the slope on that is 1 over 8. And it doesn't matter, okay? It's still a function. This is a straight line with the function going down. It's got a negative function. It's still a function. But maybe if I go over like this, now I've got a curved graph. My slope is changing all the time, but I'm still a function, okay? As a matter of fact, as long as my line keeps going from left to right, it can change, it can curve, it's still a function. The only thing that makes it stop being a function is if it's going along and then it turns around and comes back. As soon as it starts turning around, that's where it stops being a function. So technically, a function is a graph that is vertical. When it reaches the vertical point, when it starts turning backwards on itself, then it stops becoming a function. So how does that look in our rules, right? So our rules are like our equations. We are used to, if I say y equals 3x, okay, the rule on this is if I have, I put in an x, I multiply by 3, and I get out a number. So negative 3 times 3 is negative 2 times 3 is negative 6. Negative 1 times 3 is negative 3. So these are our points. Every time I put in an x, I get a y. And the y is always different. Now, it doesn't matter if the y is always the same, right? So if y equals 5, on these, all of the points on this line, the y is always 5, right? If I get the table for this, if I put in a negative 2, I get out of 5. If I put a negative 1, I get out of 5. Because this rule is any number I put in, I get a 5. Okay? As long as the number I put in gives me only one number out. So if I try something weird, like the equation for a circle, okay, so here's a nice circle. If I put in a 0 for x, I get out a 1 here. But if I put in a 0 for x, I can also get a negative 1, okay? And you'll notice I can't get a graph for this one. It doesn't give me the table option because it's really hard to make the table, because if I went like this and put in a negative 1 or put in a 0, I could put a 1 on the x side. But if I put in a 0 here, I could also put a negative 1 in there. So I can't really make a table on there. So there is no table I can make for this equation without a repeat, right? So if I'm looking at a table of data, and on the X side, if I've got the same number, and on the Y side, I've got two different numbers. So if I put in a 1 and I get a 3 here, and then I put a 1 again and I get a 5, that's not a function. Because if I tried to graph that, if I put in a 1 and got out a 3, and then I put in a 1 and I got out a 5, okay, then I would have 2 points, a 1, 3 and a 1, 5, that are on the same line, x equals 1. And I can't have that. I can't have a line that goes straight up and down. I can't have a line that goes backwards. All right. So we'll skip down to the formal definition. A function is a rule that assigns to each value one quantity to each value of one quantity a single value of a second quantity. So if I put in an x, I only get one y for each number that I put in. The y could be different, but when I put in an x, I always get the same y out. Okay. Even though we might not have a formula for the rule, we see that the functions do arise in real life situations. That's all for today, and we will see you in class.